So for LCM, GCD is 10, we calculate already. B is 20, is multiplied 20. Okay, then you use A, which is 15, to divide by 10 equal to 5. Then 5 multiply this 13 equal to 150. That's how we calculate LCM, least common multiple. Then after doing this, we can take a look about the question, LeetCode questions 878. N's magical number. A positive integer is magic if it is divisible by either a or b. Given three integer NAB, return N's magical number. And since the answer may be very large, then return the modular 10 to the power of 9 plus 7. Then how do we solve these questions? So we can take a look about a simple algorithm. Firstly, we got the GCD, which is you do this, you return this, or otherwise you return x. If you y equal to 0, then LCM is the same logics as what we described in here. And then how we do, we use binary search. Then L equal to 0, R equal to N multiply minimum of A divided by B. Because this is the range we will define. So the answer of the N's magical number will be between the range of this range. The range is between the in here, right? So it's between the minimum A and B, then multiply by N. This is the range, right? You won't go beyond this range. You get the smallest number and multiply N. You won't go beyond. Then you get the L, R. You do the binary search, the classic binary search. L less or equal to R. Then you check this, M divided by N, M divided by B. For example, this. As long as this is greater than N, then you get the answer. Then you keep doing the binary search until you find the answer. So how this works is, for example, A equal to 2, B equal to 3. Then you get this. This is 2, 3, 4, 1, 2, 3. This is the N's, right? N's. Then you get this LCM. This is a range, right? We just now said this is a range, and this is a it's a if condition, right? This is a if condition of N's numbers. For example, this is x. This x is M. M is is in the middle, and you do the search. And this is a range, the boundary, right? This is a boundary for this one. This is a boundary, right? For this boundary, and you get the middle and do the binary search. And what's this? This is a condition that whether this whole thing, this M is the middle point, right? The middle point divided by M and 7 and minus the LCM 35, right? As long as this is greater than the N's number, then you keep. If it's greater, you search on the right side, on the left side, right? You search on the left side. This is the boundary. You search on the left side. Then R equal to M minus 1. Otherwise, L equal to M plus 1. Another very important concept is called principle of congruence. It's a numbers wrap around after reaching a certain value called modulus, right? So this is a principle of congruence. It's an arithmetic that deals with remainder when dividing numbers. To explain further, if two numbers A and B leaves the same remainder when divided by a number M, when we see that A and M are congruent modulo M, mathematically is expressed as A congruent B mod M. For instance, consider the modulus of M equal to 12. 26, 14 are congruent modulo 12 because both leave a remainder of 2 divided by 12. And this is congruent modulo 2, congruent modulo 2 because both leave remainder 2 when divided by 12, right? So the concept is essential for various mathematics and computer science, especially in cryptography. The point you provide earlier seems so. This is a and you can see how we do the principle of congruence for addition and multiplications. You take the modular directly. For subtraction, you do a minus b plus m modulo m. Why? Because you won't return a negative number. So for example, this is a this and this plus actually equal to this. Then my modulo m equal to this a is the same. Is the same applied to multiply. Then for minus situation, you can see this one any a number mod 7 equal to minus 2 or mod 7 equal to 5 is the same because e plus 2 is all can be multiplied by 7, so it's the same. Essentially it's the same. Then for example, for this example, right, this is for the subtraction, this is a equivalence, right? How can you do the principle of congruence for this example? For the subtraction, it's doing this. You have to plus m and minus m. So it's a bit different from the addition and multiplications. For example, for this one, right? 2, this one mod 7 is 2. This one mod 7 is 18. Mod 7 is 4. Then this one is 8. If you take directly, is 8 is 5. But for you can say here, you plus 7 mod 7 is you better plus 7 because this is the same. But the question say cannot be negative, right? Cannot be negative. In the question 878 cannot be negative. Then you take this.